Hello class, welcome back to the unit on triangles. Yay! Today we get to cover a really cool thing. We're going to learn about corresponding parts of congruent triangles. So let's talk about that, shall we? Yes, corresponding parts of congruent triangles. So this corresponds to chapter 4, section 4 in our textbook. But what are we going to do? We're going to talk about proving parts of triangles congruent. And then we're going to talk about using the reason corresponding parts of congruent triangles are congruent. What some people call CPCTC, so they say. And then it's all about proofs, proofs, proofs. Yay! Let's do this. The first and really only note, because there's only one note, is that if triangles are congruent, that means every pair of their corresponding parts, remember, 6 parts in a triangle, that means every pair of corresponding parts are congruent. So if we can prove triangles congruent, then we can prove any parts congruent. Okay, that's a huge distinction. And Katz, what are you talking about? Let's just jump in, shall we? Yes. Proofs. So let's talk about proving triangles congruent. We have a diagram here. We're given a few things, and we have to prove that segment KB is congruent to segment AC. What is going on? Where's segment KB? Here. And where's segment AC? Here. How in the world are we going to prove those pieces congruent? We're not proving triangles. We're proving parts. Okay? So now we got to do some thinking, right? So let's think this through. We're trying to prove a part, right? We're not trying to prove a triangle. We're trying to prove a part. But in order to do that, the question becomes, can we first prove the triangle's congruent, right? So we got to think this through. This is what we're given in the diagram. We have a one arc, 2 arcs, and 2 arcs. So we have 2 angles. Is there anything else that we can prove in this diagram? And so hopefully by now, from all the practice we've done in previous lessons, you can see, you know what we can do? We can totally prove BC is congruent to itself. We can do that. That's the reflexive property, right? And if we had BC congruent to itself, we would have angle, angle, side, angle, angle, side. And guess what? That proves triangles congruent. So can we first prove triangles congruent? Yes, yes we can. Angle, angle, side. And if we can prove the triangles congruent, we can prove the parts congruent because of that first note. So I haven't even done anything, and we already have our game plan. Okay, this is the important thing with proofs. What's the game plan? How can I do it? And we've just done that. I've got angle, angle. If I only had a side, we do reflexive property. So now angle, angle, side. Now we have the triangles. Let's get the parts. So let's dive in. How's this proof going to work? Well, we start with what we start with, which is given, right? We know that. So we have our 2 things that are given. So we have, in this given statement, we have established our 2 angles. Okay, so that's that given statement. We've got our 2 angles established. Now, what are we missing? We're missing the side. So how can we prove that side congruent? By using the reflexive property. We can now establish that segment BC is congruent to itself. Okay? So we have segment BC congruent to itself. That's the reflexive property of congruence. And so now we have, just like in the previous lesson, angle, angle, side. Angle, angle, side. And now we can establish that both triangles are congruent. One word of caution. Order matters. So if I call this triangle up here, if I call it BKC, BKC, 1 arc, 2 arcs, C, I have to call the other triangle in the same order, CAB, 1 arc, 2 arcs, B. Okay, so order matters when you're naming your triangles. That's important. Okay, so we can say that the 2 triangles are congruent. Why? Because we've established angle, angle, side congruence. Okay, angle, angle, side, angle, angle, side. Now we have the triangles congruent. Now every part is congruent. So remember, we're trying to prove a part. So how do we prove KB and AC congruent? Well, if we've got the congruent triangles, all the parts are congruent. So remember from the original thing, this is the reason. The reason is corresponding parts of congruent triangles are congruent. That is a reason you must know, you must memorize. And again, some people say CPCTC. I'd rather not, but whatever. I'm not judging. So we have that. So if we can use that reason, we're done. And guess what? We're done. Now that we've established our triangles, we can establish our parts. KB and AC are congruent. Why? Corresponding parts of congruent triangles are congruent. Proof done. So we come up with our game plan, and then we established. And I know you might be thinking, wait, I don't get it, Mr. Katz. Can you do this one again? No, you can do it again. Hit pause and rewind. What I'm going to do is another one. That's right, another one. Let's do another proof. So we have given statements, and we have to prove parts. So we think, game plan. Once again, we are trying to prove parts congruent. Can we first prove the triangles congruent? Right? Can we first prove these two triangles congruent? Yes, we can. Side, angle, side. How can we possibly use side, angle, side for these triangles, right? We got to think this through. This is the hard part. Y'all got to do this, right? So we have our side here and our side here, side here. We need the included angle. Can we prove that included angle congruent? Yeah, kids. Vertical angles. Remember, vertical angles are always congruent. So we have our game plan. Once we get the triangles, now we can prove the parts. So let's do that. So the first things first, I'm going to throw down my givens. Bam, my givens. I got my two sides congruent. That's given. Now I need my angle. So I have to come up with the angle. And how am I going to prove these two angles? Remember, vertical angles are always congruent. So order matters again. If I call this angle CAB, I have to call this angle EAD. Order matters. CAB congruent to EAD. Order matters. Why are those angles congruent? Because, kiddies, vertical angles are always congruent. Okay? Once we have that, we now have our congruent triangles. So now we can claim that the two triangles are congruent. Why? Because we're proving parts. Okay? So we must first go to the whole triangle before we go to the parts. So we can establish the two triangles. Remember, order matters, but look at this little cheat. If I already had the order for the angles, let me just call it triangle CAB is congruent to triangle EAD, so the order matters. And how can I prove those are congruent? Side, angle, side. Once we have the triangles congruent, now we have all of the parts congruent. Again, the note, corresponding parts of congruent triangles are congruent. So angle C is congruent indeed to angle E. Why? Because corresponding parts of congruent triangles are congruent. Done. All right? Again, Mr. Katz, I don't get it. Can you do it again? No, you can. Hit pause and rewind. I'm doing another. Word problem. Yay! Let's talk about clever Thales, shall we? So Thales, Greek philosopher, said he developed a method to measure the distance of a ship at sea. He created a compass by nailing two sticks together. What? He created a compass by nailing two sticks together. That's cool. Then, standing on top of a tower, he would hold one stick vertical and tilt the other until he could see the ship S along the line of the tilted stick. And then he would nail it. With that compass setting, he would find a landmark L on the shore along that same eyesight line of the tilted stick. How far would the ship be from the shore? Right? And of course, right now you're thinking, what? Did that just say? All of that said this. Given angle TRS and TRL, and by the way, in case you can't see it too clearly, R is down here, T is up here, S is that little boat, and L is that little tree. Okay, so we have those things going on. So given those things, TRS, and TRL are right angles, and angle RTS is congruent to angle RTL, which is what's said, by the way. Let's translate these words in case you want to see how reading works. So the first thing he said is standing on top of a tower. Funny, towers have a tendency to be perpendicular to the ground, unless you're in Pisa. So tower has a tendency to be perpendicular to the ground. So because it says standing on top of a tower, that's why we can say this given statement. Okay, so it's all about reading and understanding stuff. So we can say this statement because towers are normally perpendicular. The other thing we can say is from this little gem, with this compass setting. So it says with this compass setting. he would find a landmark on the shore. What does that mean? That means the angle he used to spot the ship with that compass setting to find something on the shore, he's saying these angles are the same. These angles are congruent. And that's why we can establish this. RTS is congruent to RTL. Okay, so there's neat reading going on here. The question then becomes, can we prove RS and RL congruent? Can we prove RS, distance from the tower to the ship, and RL, distance from the tower to the tree, congruent? Okay, and, well, here we go again. We got to think. Think. We're proving parts. Can we prove triangles congruent? And yes, we can. If we have our right angle here, right angles here, these angles are congruent here, can we prove this side to get angle side angle? I wrote the thing wrong. Can we get angle side angle congruence? And the answer is yes. So yeah, let me fix that. Angle side angle. So yeah, we can use angle side angle to have our two triangles, and then we can prove the parts. So let's jump in, shall we? I'm going to do something here kind of crazy, so hang on. Watch this. Normally we've been throwing down all of our givens. I'm not going to do that here. I'm going to split my givens up. Because this doesn't say that the angles are congruent. All right? It just says they're right angles. It doesn't say they're congruent. So I'm going to split these up, because I must establish congruence first. So this is a neat little thing. My first argument is going to be that given statement about right angles. Angle TRS and angle TRL are right angles. That's given. I must split that up. Why? Because this doesn't say they are congruent. I need to say they are congruent. So how in the world can I say that those right angles are congruent? By this way. By saying that those angles are congruent because all right angles are congruent. And that's important. That's an important distinction. So I can't just the givens and then go back, like backtrack, and then say, hey, remember when we said they're right angles? Well, guess what? They're congruent. Split them up. They're right, so they're congruent. Now we've established that. Now we can have our two angles. Okay, so RTS is congruent to RTL. That's the other given. Okay, so now I can say that. So now we have our two angles, angle, angle. All we need is the included side, which we do. How do we have the included side? Good old reflexive property. So we have the reflexive property. RT is congruent to itself. Okay, so see how we're doing this. We're thinking it through. And now that we have our angle, our side, and our angle, we now have congruence. And again, let me change that because I made a boo-boo. We have our angle, our side, and our angle. We now have congruent triangles. And with congruent triangles come congruent parts. Okay, so we can say, again, corresponding parts of congruent triangles are congruent. Now, what's neat about this? Why would Thales need to do this in ancient Greek? Because there's a lot of wars going on around that time, right? So what's the purpose of doing this? Not the ship going out, it's the ship coming in. The whole purpose he does this is for defense. This is very, very clever. So if a spotter up at the top of the tower can see a ship, make a measurement, and have someone downstairs find the measure from the tower to the thing he sees, we now have a distance, and then he does it again a little while later, like a few minutes later, he measures it again. Now he can tell the speed of the ship and when they're going to arrive, and then we can play defense if we have to, so he can protect Greece. Clever dude, that guy, and can protect Greece and protect the Senate and democracy and blah, blah, blah. So that's why we're all not Persians right now. Anyway, that's how that works. Mr. Katz, do it again. No, you do it again. Moving on. Next proof. More proofs. So this is a good one. We have the situation here, the diagram. M is the midpoint. What the heck does midpoint mean? Midpoint cuts in half. What does half mean? Half means we have two congruent pieces. It's a clever thing. So again, we got to think, can we get congruent triangles? So here's our setup. We have our given statement. And again, I'm going to split these givens up. M is the midpoint of BC. This doesn't say anything about congruent, does it? No, cats. This doesn't say congruent, so I have to split the givens because I need to establish congruence, right? So that's the difference. So let me start with the first given, AB and AC, given. Now I have a side, right? The second given statement doesn't give me another side. the second given statement is just a statement. It has nothing to do with congruence. However, it can lead us to congruence because M is the midpoint of BC. We now know that BM and CM are congruent, and that's what we have to say. That's the next thing. BM and CM are congruent. That's the definition of midpoint. And that's the argument for that, by the way. And now we have our two sides. So what in the world are we going to do with our two sides? Can we get these two triangles congruent? Yes! Side, side, side. We'll get there. We have our third side. AM down the middle. Boom, boom, boom. AM down the middle is congruent to itself. Reflexive property, we now have side, side, side. We now have congruent triangles. With congruent triangles, we now have congruent parts. And so we can totally prove that. Okay? So that's how that one works. If that was too quick for you by this time, dude, totally rewind. But anyway, I'm moving a little bit faster. It's all about game plans. Next proof. Here's a neat diagram. I'm not giving you much in the picture. Now you've got to read. So let's read. Given WX is congruent to ZY. Well, I don't see any marks there. Great. Make them yourself. WX, ZY. Congruent. WY, ZX. Congruent. Can we prove these parts congruent? I hope you see yes, because we're going to eventually get into reflexive property. And then we'll have side, side, side congruence, and then we can prove our parts. So what would that look like? Now again, since I'm given two congruent statements, I'm giving them two congruent statements, I can throw them both down. Okay? Blam. I'm throwing them both down for given. Now I give my reflexive property, right? So the one down the middle. Now I can establish triangle congruence, and now I can establish parts. Okay? So that's how that works. Bam, bam, biggity bam. Next. More proofs. So here's another one. So now I have this. Again, I'm not giving you hash marks. I give you right angles. Is that cool? I hope so. Angle ONL. Where in the world is that? ONL is right here. And then angle MLN. MLN is right here. Okay? And O and M are right angles. Can we establish congruence? And the answer is yes. Can I throw both givens down? No. Although I did. This is an incorrect proof. I'm glad I wrote that. I can't just up and say this. Angle O is congruent to angle M. That wasn't given. Okay, that wasn't given. So I can't write that there. I have to do a few more things. I have to say angle O and angle M are right angles. That's what was given. Okay? That's what was given. And then I have to say angle O is congruent to angle M, because right angles are congruent. It's such an important distinction to make. It really is. And I'm sorry I messed that up, but at the same time, I'm glad I did, because now you can see that working, right? Anyway. So now we have our two angles congruent. Do we have a side? Yes, we do. Reflexive property down the middle. Boom. So now we have angle, angle, side, and angle, angle, side. Okay? So now we have congruent triangles, and with congruent triangles come congruent parts. And that's how all that stuff works. Hopefully you can start seeing how the thinking comes together. Practice, 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 please, because proofs are so much fun. And now we are all about corresponding parts of congruent triangles being congruent. Peace out.